Hi friends. Today we will see the topic dimensional quantities, dimensionless quantities, principle of homogeneity. So there are four types of classifications called dimensional variables, dimensionless, dimension constant and dimensionless constant. So we will see each of these. First is dimensional variables. Physical quantities which possess dimensions and have variable values are called dimension. Example, length. The unit is meter. First is meter per second, expression meter per second square. Dimensionless variables. Physical quantities which have no dimensions but have variable values are called dimensionless variables. Specific gravity. We have seen the definition of specific gravity is ratio of density of the substance to be found divided by density of the standard substance or standard fluid like water or gas. Okay. So numerator and denominator, since we have same unit, it gets cancelled, so there is no unit. Similarly, strain, change in length by original length, so the length and length have the same unit, so it gets cancelled. So that is the reason we don't have any, there are no dimension, it is a dimensionless variable. So dimensional constant, physical quantities which possess dimensions and have constant values are called dimensional constants. Example, gravitational constant, Planck's constant. So we know that gravitational constant, Planck's constant all have specific values which is fixed by scientists. So we just take these values and use it. So that is called as dimensional constants. Okay. Dimensionless constant, quantities which have constant values and also have no dimensions are called dimensionless. Example, pi. Pi, we know it does not have any dimension but are units, but it has standard values. The principle of homogeneity of dimensions. The principle of homogeneity of dimensions states that the dimensions for all the terms in a physical expressions should be the same. For example, in a physical expression, v square is equal to u square plus 2as. The dimensions of v square, u square and 2as are the same and equal. That is L square t to the power minus 2. So, application and limitations of the method of dimensional analysis. This method is used to convert a physical quantity from one system of units to another system of units. Then second, check the dimensional correctness of a given physical equation. Establish relation among various physical quantities. Sometimes in India we generally use SI units, but in other countries they will not be regularly using centimeters or meters. They will be using some other units like inches. In UK or USA or some other country, they may be using inches. Or if we are using kg as a standard unit, whereas they may be using some other quantity as a grams or some other thing as a standard unit. So we are using SI units, they may be using CGS units. So in those cases, suppose if they send a product, okay, suppose if we have to measure that product, everything will be in CGS units. So in those cases, we have to convert that CGS units or one form of units dimensioning system into another form for our own understanding. So that is the reason we have a dimensional analysis. To convert a physical quantity from one system of units to another. Okay. So we will see this using an example. How we get converted from one unit system of units to another. So convert 76 centimeters of mercury pressure into Newton meter square using the method of dimensions. Okay. So if you observe this, you will see 76 centimeters of mercury. So this is in centimeters, whereas they are asking us to convert from 76 centimeters of mercury into Newton meter square. So here itself you will see the conversion is from centimeter to meter. When they say centimeters of mercury, it means they are using CGS system. So we have to come to the conclusion they are using CGS system. In CGS system, 76 centimeters of mercury pressure is equal to 76 into 13.6 into 980 Dyne centimeter square. Okay. Now, before going to further, for those who have not read what is a Dyne, we will just go through it in just 1 minute. Okay. So we know that work done is equal to force into displacement. In SI units, the unit of force is Newton and the unit of displacement is meter, and the final unit for work done is Joule. In CGS units, okay, centimeter gram second, okay, centimeter gram second, we have the unit of force is Dyne, okay. In the CGS system, the unit of force is Dyne, the unit of displacement is centimeter. So when they ask what is the unit of work in CGS system, you have to write as erg, not as joule. Okay. The question will be asked as what is the relationship between joule and erg. So 1 joule is equal to, that is joule, work done in a SI unit is equal to 1 Newton into 1 meter. So 1 Newton is equal to 10 to the power 5 Dyne, that is unit of CGS system, into 1 meter is 100 centimeter. Now we have 1 joule is equal to 10 to the power 7 erg. Here, because you know that work done, okay, is equal to, work done in CGS is equal to Dyne into centimeter is equal to erg. So here Dyne and centimeter, so the final unit becomes 1 joule is equal to 10 to the power 7 erg. Okay. Dyne is a measure of surface energy. So some may be wondering what is the unit Dyne used for. Okay, higher the Dyne, better the paint and glue adherence to the surface. Suppose if you make a paint on the surface of a container, okay, or a cylinder, or the thermal cylinder. So we have to, in order to find out how much a paint adheres to a particular material. Suppose if they paint it on steel, what is the amount of adherence, means how much of attachment, okay, to the particular surface. But so suppose if they paint it on copper, what is the amount of adherence to the surface? The higher the Dyne value, the higher the adherence or attachment. Okay. Now we will come to this problem. Now P1 is equal to P2, that is pressure 1 is equal to pressure 2, that is we have to convert the CGS, that is CGS units into SI units. Okay, this is S to be SI units. So pressure 1 is taken as CGS units, pressure 2 is taken as SI units, P1 is equal to pressure 2. Only thing is we are just going to convert. Now we represent mass, length and time as M1, L1 and T1. That is the CGS unit is taken as 1. Okay, CGS unit is taken as 1. Now we take the mass, length and time of the SI unit as 2. Okay, we just represent it as 2. Okay, and the power values will be represented as ABC, that is common for both. Now what is that we have to find out? We have to find out the 76 centimeters of mercury pressure into Newton per meter square. Okay, now that is we have to find P2. Okay, that is P2 is we have to find the pressure in terms of SI units. That is P2 is equal to, we bring all these values this side. P2 is equal to, P1 remains the same. This M2 comes here. Okay, M1 divided by M2, L1 divided by L2, T1 divided by T2. All whatever values are here, this comes below the M1. Okay, because we have to find P2, and the values for M1 and M2 both are A, and values for L1 and L2 both are B. The values for T1 and T2 are C. Hence, we make a common bracket and put the common value for M1 and M2 as A. Now, we know that M1 is equal to 1 gram. Okay. m2 is equal to 1 kg, because in CGS units, centimeter, gram, second, right? So this is gram, centimeter is L1 is centimeter, L1 is centimeter, G is gram, and second is 1 second, T1 is equal to 1 second, S is 1 second. Now similarly here in SI units we have mass as kg and length as meter and time as seconds. Okay. Now many of you may be wondering how A equal to 1, B equal to how B equal to minus 1 and C equal to minus 2. So here what is that we have to find out? We have to find out the pressure. Okay, what is the formula for pressure? Pressure is equal to force by area. What is the formula for force? Kg meter per second square. Kg meter per second square is the unit for force. And what is the formula for area? Meter square. So we write it as kg meter per second square into meter square. When we cancel this meter, okay, meter, here 1 meter get cancelled. This, when it goes up, we will get as pressure is equal to, pressure P is equal to kg, okay, meter minus 1, second minus 2, okay. This A is kg, that is mass, that is, if when it is just written as kg, it is assumed as here 1 exists, okay. Now B is equal to minus 1. Now B is length, that is meter. B is length, we have seen. C is time, seconds, that is minus 2. Kg meter to the power minus 1, seconds to the power minus 2. This comes from the formula pressure is equal to force by area. Now P1 we write it as, we know that P1 they have already given, that is pressure 76 centimeters of mercury, 76 into 13.6 into 980, we write it as they have given, okay. Now here we write this M1. What is M1? The pressure value in CGS units, 1 gram divided by M2, that is in kilogram, 1 gram 1 kilogram. L1 is in CGS units, whereas L2 is in SI units, 1 centimeter divided by 1 meter. Similarly 1 second and 1 second time is same. Now here units ABC, in ABC places we have to write this 1, in the mass area we have to write 1, in the length area we have to write minus 1, because B is minus 1, that is meter is minus 1. The seconds area we have to write minus 2, okay, because the time is minus 2. Again we have a rule that we have to convert all these into a common unit, right? Each of these, on the numerator we cannot have gram, and the denominator we cannot have kg. So in order to bring it into a common unit, we are converting the gram into kilogram. That is the reason we know that 1000 grams is equal to 1 kilogram. So 1 gram is equal to 1 by 1000th of a kg, which is equal to 10 to the power minus 3 kg. We know that, we have seen that in the previous videos. Now, so they are writing 1 gram is equal to 10 to the power minus 3 kg. Now 1 centimeter is equal to 10 to the power minus 2 meter. We know that 100 centimeter is equal to 1 meter. So 1 centimeter is equal to 1 by 100 meter. So we are writing it 10 to the power minus 2 meter. And 1 second we are just writing it as it is. Now we have brought all this into a common unit called kg, meter and second. Now we are just multiplying it, and when we multiply we get finally P2, that is 1.01 10 to the power 5 Newton meter to the power minus 2. Okay, now I hope you would have understood, students. So in this problem, if you observe, we have seen the 1.1 into 10 to the power 5 Newton meter to the power minus 2. So some of you may be having some doubts about how we got this Newton meter to the power minus 2 from this. So I will just give an explanation for that. Now we have 10 to the power minus 3, okay, kg to the power 1, 10 to the power minus 2, 10 to the power minus 2 minus 1, now meter to the power minus 1, okay, and second to the power minus 2. Now we take away the values separately and multiply. Now we will talk only about the unit. Kg plus 1, meter minus 1, okay, meter minus 1 just comes here, kg comes here, second minus 1. Now again we have kg, we are writing it clearly, kg plus 1 can be written as kg m to the power minus 1 s to the power minus 2. Now we have to convert it into the SI units, that is unit form. So we know that 1 Newton is equal to kg meter by second square. In order to bring it into this form, we are trying to convert this, put this value in terms of, we don't have positive m here, whereas the value Newton has positive m here. So in order to bring it, bring positive value into that m, we are just writing this as m plus 1, m minus 1, which is actually 0 when you strike it off. Now m minus 1 is written as it is, okay, here this value is just written here, then s minus 2 is written as it is. Now kg meter by second square. Second square is this, s to the power minus 2 comes down, okay. Now we are left with kg, this is taken here, this is taken here, s to the minus 2 comes here. Now we are left with m to the power minus 1, m to the power minus 1, that is written as m to the power minus 2. Kg meter per second square is written as Newton, and meter by second square is written as Newton, and this m square, m to the power minus 2 is written here. So now we have that value, P2 is equal to 1.01 10 to the power 5 Newton meter to the power minus 2. That's how we get this n m to the power minus 2. For those who have not understood how we got this, I am just giving the explanation. Thank you, friends. If you have any doubts, write it in the comment section. For those who have subscribed, thank you. For those who are not subscribed, kindly subscribe and share. Thank you, friends. Thank you.